Today we want to talk about module 4. Now, in previous module, all our equation is of the form y equal to fx. If you have this kind of equation, then we can use the rule in the module 3 to find the derivative. However, when we have implicit equations such as the x squared plus xy plus y squared equal 5. So this total different from everything we learned from module 3. Then we need to use implicit differentiation. So what's the implicit differentiation? That means we need to take derivative term by term. Remember, with respect to x. So then solve for dy dx. Okay, let's see the example. If I have equation x squared plus xy plus y squared equal to 5. So step 1, I need to find dy dx term by term. So x squared term, I take derivative, I get 2x. Now xy, this is a product of two functions. So xy, we need to use product rule. So derivative of x times y with respect to x, we get f prime g plus g prime f. So y times derivative of x with respect to x plus x times derivative of y with respect to x. Then we get y plus x times dy dx. Then last one, y squared term. Y squared, we get 2y dy dx. Remember, y is a function of x, so you always have term dy dx. Now x squared, you only get 2x, And last term 5, d5 over dx, 5 is constant, so derivative is 0. So now we have equation 2x plus y plus x dy over dx plus 2y dy dx equals 0. Second step, we want to solve for dy dx. So now we rewrite. So 2x plus y plus x dy dx plus 2y dy over dx equals 0. So these two are like terms. We factor out dy dx. So we get x plus y equal 2x plus y will move to the other side. So now divide both sides by x plus 2y. So I have dy over dx equal negative 2x plus y over x plus 2y. So that's basic principle of implicit differentiation. The next example, we want to find second derivative. So for x squared plus y squared. Now to find second derivative is more complicated. So first of all, we find first derivative. Follow the example on procedure on example 1. So x squared, I get 2x. Y squared, I get 2y dy dx. Then 5, I get 0. So now I solve for dy dx. So dy over dx is negative x over y. So that's the first derivative. Then we want to get second derivative. So d squared y over dx squared, the second derivative. That means d over dx this is first derivative. So this is a quotient of two functions. So we use quotient rule. So by quotient rule, I will get y squared -1 times y minus -x times dy over dx. So I can say this negative, I get positive x dy over dx minus y over y squared. So I get y squared dy dx, be careful, dy dx is negative x over y, dy dx. So replace first derivative by, we get negative x over y, then copy minus y. So now the numerator becomes negative x squared over y minus y squared over y. Y is y squared over y, over y squared. So now this y goes down, so you y to the third. Numerator, negative x squared plus y squared. So it's tricky. X squared plus y squared is 5. By the question says x squared plus y squared equals 5. So this x squared plus y squared is 5. So now our second derivative is -5 over y to the third. Now textbook has other example, but we always need to use first derivative and the original given conditions.